Good morning, everyone. I am Bonusri Chatterjee. I will be your guide in this exciting journey through data structure and algorithm, or you can say DSA in a short form. Whether you aim to build powerful application, solve complex coding problems, or you want to crack any top MNC's interviews, then DSA will be your foundation. If you want to plan to take the preparations of gate exam and if you want to take the interview preparation, then DSA subject is very crucial for your preparation. You have to learn this subject very carefully and attentively. I will assure you that I explain every topic in DSA in very easy way that you can understand. Now start DSA. Before I start the subject, then first you have to know the prerequisite subject that you covered in your previous semester. I think you know the C language, how to run the program, how to compile the program. You know, I think no. Oh, and you have to know that what is variable, what is data type, what is if else, what is functions and pointer. Please, you revise all those things that you can understand this subject effectively, and it will be better to understand this subject. Okay. So before I start any subject or any topic, then you ask yourself, there is a three question. What is this and why we learn this? And another one is where we apply it or what is the real time applications of this. So first you come to the first one, what is this? So before we learn that what is this, first ask yourself that why we learn DSA. Just think to Google Maps. Google Maps find the shortest path, and in any shopping app, if you save any item in your cart, then it's showing that most relevant results, most similar type of result. Also, if you see any social media, then it's showing your mutual friend. Behind all these features are efficient data structure and algorithm present. So, in the world of programming, writing a working solution is not enough. So, it must be fast, memory efficient, and scalable. That's where DSA come in. The main motto of DSA, data structure algorithm, the main motto is you have to design in one algorithm which is memory efficient and which will be fast or it takes less time. Now come to the point that what is DSA. In a DSA, there is a three term. One is data, another one is first one is data, second one is structure, and third one is algorithm. So we come one by one. What is data? First one is what is data? Just see around you. Everything is data. This mouse also a data, this laptop also a data. So data is real time entity. Raw values or facts, numbers, your name, your roll number, all are data. So in this era, huge amount of data present. Now next term is structure. Structure means what is the meaning of structure? Structure means organizing the things or organize those data. Okay. Now come to the data structure. What is data structure? Then we can say data structure is a way of organize and storing the data that we can use efficiently. What is the meaning of efficiently? Efficiently means we use those data in less time and use less memory. So data structure is a way of organize and storing the data. Now take one example. There is a many books and you throw the books in a box. Okay, now the books are not messy. It is structure way. We're just storing the data. Now there is a many books, math books, data structure books, DBMS books, um, now history books, English books, different types of books are present. You just store it in a box. In a box, you just store it. Okay. Now I ask you to search the data structure book. Now it is not stored in a order. So when you search the data structure book, then it takes times. Yes or not? Because we store the data in randomly. But when we store those data in a order, or now I store those books in a alphabetically order. Okay. Then if I ask that please find the data structure book, then you just maintain the alphabetic order, and when D comes, then you search and data structures books are there. Yes. So can I say this data structure is a way of only way of organize the data and store the data? Not. DSA is basically it's established the data, a logical connections between the data. DSA establish a logical relationship among the data. When I store the data in alphabetically, then we make one relationship, one logical relationships, this alphabetically ordered. So DSA, the definitions of DSA is a data structure established a logical relationship among data elements and stores them in a structured format in memory, allowing efficient access and manipulations. That we can access, we can create the data, we can delete the data, we can update the data. Okay, so it's clear that what is DSA. Okay, now come to the next point is why we learn this subject. What we learn first, we have to know that what will you learn in this subject. Basically, the key points of this subject is array, memory allocation. Memory allocations means we covered here the static memory allocations. We covered here static memory allocation, static memory allocation, dynamic memory allocation, okay, and we also covered the linked list, stack, queue, tree, graph, and searching and sorting algorithms. So in your syllabus, we covered all those things one by one. Okay, now come to the why do we need this data structure. Okay, now why do we need data structure? If data structure is not present, then what happens? We know in our real life there is a large amount of data. Without proper structure, data becomes messy. it takes more time and memory to work with. If I want to search anything, then it takes too much time. If the data becomes messy, if data messy, then it takes too much time to search, to access, to traverse the data, or it takes too much memory. As well as if the data structure is not present, then programs become slow and inefficient. Yes or no? That's why we need data structure to use the data in efficient way. Also, to save the time and to save the memory, we need data structure. Okay. Now, why we learn the data structure? Second question is why we need the data structure. It's clear that why we learn the subject is clear. What is data structure is clear. Next one is why do we need data structure is clear. Now come to the real life analogy, or what is the applications of data structure. Now I just want to arrange the books on bookshelf. What is the if we store those books in a bookshelf, then we maintain one array. Actually, basically, we don't know till now what is tag, what is queue, what is graph, what is tree, but all those are in a data structure. We explain one by one that what is tag, what is queue, what is graph and tree. Basically, the real life, in a real life, we use this stack operation in a undo and redo operation is in a word. Also, in a ticket counter, basically queue use in a Google map, the graph use in a family tree, basically the tree use. Now come to the basic operations on data structure. We insert the data. In a insert, when we insert the basically, first of all, you have to know that data structure not a programming like a C, Java, Python. In a data structure, we use the program. In this course, data structure we complete using the C language. So, the basic operation in data structure, when we organize the data, then there is some basic operations to structure the data. The way of structure the data, we use some basic operation, that is insertion. We can add new element, and now next operation is delete operations. We can remove the element, and search, we can find the element from anywhere, and next one is update, we can modify the data at any position, and traverse the data, go through all the elements. Okay, so those are the basic operations of data structure. Now come to the type of data structure. Mainly, data structure is two types. One is linear data structure, another one is non-linear data structure. So what is linear? Linear means elements are arranged in a sequence, one after another. So this is linear data structure. We already know what is array. Yes, and we also know that array, how to write the array. Yes. So array, what is array? Array is a collection of similar type of element which is stored in a memory contiguous way or continuous way, one by one. Okay. So this is an example of linear data structure. Basically, we access the array data through the index value. Okay. So its index starts from 0, 1, 2, 3, 4. Okay, so it's arranged in a sequence. So this is a one linear data structure. Another one is linked list, stack, queue. Okay, and next one is non-linear data structure. What is non-linear? Means it's not linear. It's not maintain the sequence order. Then what type of structure it use? Elements are connected in a hierarchical and network structure. Okay. So it's maintain the hierarchical order or network structure. So example of non-linear data structure. This is tree which maintains the hierarchical file system, file trees. Okay. And next one is graph, which is follow the network structure. Basically, we know graph is a combinations of vertex and edges. Okay. So now come to the points. I just said that DSA, the main motto of DSA to find that which one is takes less time and which one is takes less memory. But how it measured? It measured through 2 points. One is time complexity, another one is space complexity. Through the time complexity and space complexity, we can found that which data structure is best. Okay. What is time complexity and space complexity? I will explain later. But what is time complexity? Time complexity means total time required to complete the program. This is time complexity. And what is space complexity? Total amount of space required to solve the program is called the space complexity. Okay. Now come to the point DSA. We explain what is data and what is structure, and we also complete what is data structure. Now come to the point what is algorithm. Now there is a one part what is algorithm. So what is algorithm? We everyone know that algorithm is a blueprint of a program. Algorithm is a step-by-step procedure or formula for solving the problem. Algorithm is a set of instruction to do a program. Okay. So what is the features of algorithm? First features is correctness. It produces the correct output for all valid inputs. In case of algorithm, we take some inputs and it produces correct output. And next one is efficiency. It gives the algorithm always gives the efficient result. Means it takes less time and less space. Next one is finiteness. Means there is a finite number of steps present to complete the program. If there is an infinite number of steps present, then we can't get solution for this program. That's algorithm must be finite, maintain the finiteness. Okay. Next one is input and output. It takes input and produce desired output. Next one is unambiguous steps. Means each step is clearly and precisely defined. Every step must be clear. Okay. Next come to the why do we learn algorithm. So first of all, when we learn algorithm, then first you have to know that what is algorithm. After that you have to know that why we learn this algorithm. So algorithm basically used to solve problems efficiently. It is basically used to solve the problems efficiently. Okay. And another one, it gives the efficient result That's why you can write optimized code using algorithm. Okay, so basically your algorithm parts cover in DAA, design algorithm and analysis subject. It's covered, it's preciously covered in the subject DAA. Okay, we just in this subject we basically know that what is algorithm and why we learn this algorithm and the basic steps of algorithm. Okay, now for your knowing purpose, I just write here that real world example of algorithm. Basically, algorithm, where we use the algorithm. Algorithm basically used for Google search purpose, uh, Google Map navigation purpose, banking security purpose, online shopping purpose, and social media purpose. So basically, in a Google search purpose, we basically use the page rank algorithm, and GPS navigations, it use the Dijkstra algorithm. Okay, we just write for your usefulness. Okay, next one is how to do design an algorithm. What is the steps behind the algorithm? First, understand the problem clearly. Problem means what, which program we have to solve. Okay, so when we design any algorithm, first you have to understand the problem. After that, you have to define that input and outputs, then break the problem into smaller steps, then write a step by step solution and analyze times and space complexity, then test this algorithm to different inputs. Now come to the example. We already know that if I just want to add two numbers, one is A, another one is B. We take two numbers from the user. Okay, so I write down for this program, I write down the algorithm. So first step, in a step one, there is a one first thing is start. In a step one, first step is start. Then step 2, we take two numbers A and B. Okay. Then step 3, add A and B and we got the result A plus B, which we store the result, stored in a result. And after that we print result. And the last step is stop. Okay, so when you write the algorithm, there is a two common part. One is step 1 and step last step. Okay, in a step 1 we just write start, and in a last step we just write stop. Okay, now this is a very simple program. We just take two data from the user. After that you print those additions value in another variable result and print the result. So from this algorithm we can write the program. Yes or no? Yes, we can easily write. Now see, there is a finite number of steps. There is a, how many steps are present? Only 5 steps are there. Okay, and every steps are very clear. Okay, now take another example of linear search algorithm. You already know that what is linear search. This is a one searching method. Here we take one number and we match with another number. If it is match, then we can say the number is found. Otherwise, we just print the number is not found. Okay, so we first take one array, because we know that array is a combinations of similar type of data. After that we match with the index value. If it is match, then return the index. Otherwise, it's come to the next one. So now Now see the algorithm. Start from the first element and compare it with the target value. First we take one target value which will we search. Then start with the first element and compare it with the target value. If it is matched, then return index. If not, go to the next element. Repeat until end of list. If not found, return and stop the program. Okay, it's clear. What is algorithm? Now come to the time complexity. What is time complexity? I just said that time complexity is total time required to complete the program. So here in a best case in a linear search, if I found the data at the first time, then it takes only one time. So we can say this is a base time complexity. Now I want to search any data which one present at the last. Then it takes n times n number of data. First we want to search. After that we got the result. So it takes n times. So this is the time complexity is order of n. So when the constant time present order of 1, then this is a best case. When we got the result at the last, this is worst case, means it takes too much time. Okay. So now today we complete the introduction session, that what is data structure, what is algorithm, why we learn this, and where we apply it, we completed. Yes. So next day I will start the array portions. Okay. Now thank you for today.